Rajeshwari MG. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Television and Engineering. Today we are going to concentrate on Unit 4, that is Color TV. Some of the topics that we are going to cover in Unit 4, weighing factors. Some of the factors that we need to add with the color difference signals to overcome the overmodulation. So, that thing we are going to cover in the weighing factors section. And the last we are going to discuss about PAL, color television system. We know PAL stands for phase alteration inline. This is one of the standards that we are going to use in a television system. Weighing factors. We come across the color difference and the production of color difference and also modulation of the color difference, everything. Now it is time to learn the weighing factors. What does it mean? A peak to peak amplitude of green signal. There will be a peak to peak amplitude of green signal. We can see this part will show the, this signal will signal information, the amplitude will show the Y signal, and this will be our chrominance signal. For a green signal, the amplitude will be of 0.83, and similarly for the red signal it will be of 0.3. For green signal will be 0.59 and the blue signal it is 0.11. So, the peak to peak amplitude of green signal will be plus or minus 0.83. After getting a subcarrier frequency, after modulating, that we get a resultant chrominance signal that will be of 0.83 for a green signal. For the red signal, the chrominance amplitude will be 0.76, that will be 0.76 for a red signal. The 0.76 will be the amplitude of a red signal when we get after modulation. This will be having adds its weightness of 0.3. So, the red will be having information, Y information, 0.3 will be the Y factor that we will get from Y, that is Y is equal to 0.3 R plus 0.59 G plus 0.11 is there, no, that with the R we have the quotient 0.3, this will be add with the 0.76. So, the chrominance both 0.76 plus 0.3 will be appear here in the chrominance signal. I will show clearly here. We will get 0.3 in the red and 0.76 in the Y in the chrominance signal. So, Y plus C will gives a relative composite color signal, that is 0.76 plus 0.3, that is A plus B will be appear here. And also we can observe that in blue signal 0.11 and 0.9 will going to give something called as more than 100%. So, it is exceeding, this is exceeding 100%, and this will going to cause a overmodulation. So, this will going to overmodulation and we do not get a picture of what we expected, some distortion will be there or some color mismatch will be there. So, we need to remove this overmodulation. What is the technique that we are going to use for removing this overmodulation is the weighing factors. We need to add some of the factors so that we can remove this overmodulation. That is, we can observe from the figure that is 33% of overmodulation can be appeared due to the excess of amplitudes in both Y and C signal. So, what are the components that going to compensate this overmodulation is for R minus Y and B minus Y components of the color video signal, which can be scaled down because it is having excess or high amplitude. We need to scale down it to reduce its amplitude. So, that we need to add some weighing factors, that factors is called as a weighing factors. We need to add some of the components to compensate this overmodulation. the components that we are going to add for R minus V and B minus V is called as a weighing factors. Those are 0.877 for R minus Y and 0.493 for B minus Y. So, this the compensated values are obtained by using potentiometer. This compensated value can be achieved with the help of potentiometer that we are going to use in a circuit. So, we can achieve the weighing factor for R minus Y is 0.877 and B minus Y is 0.493 using a potentiometer. And this is what the generation of composite color signal of a theoretical 100% saturated and 100% amplitude color bar signal. The same thing that we observed here is it will be having over modulation, and here we can observe the color burst signal also carrying along with the horizontal sync pulse on both the sides. Next we move on to the formation of chrominance signal. We come across the production of color difference signal and also the importance of weighing factors, why we need to use the weighing factors also. So, now it is very clear for us to how this chrominance signal will be formed. So, new amplitude of the chrominance subcarrier signals will be of 0.60. Before without weighing factor, this will be the subcarrier signals, the amplitude of the subcarrier signals will be this without weighing factor, but after getting the weighing factor, that when we add the B minus Y and R minus Y with the weighing factor, we will get 0.44 here for yellow signal. Like that for red signal we will get 0.63 using this formula, that is for chrominance signal, that is equal to square root of B minus Y whole square minus R minus Y whole square, with the weighing factor is equal to, for B minus Y it is 0.493 of B minus Y. So, whenever the value B minus Y comes here, we need to replace this with a 0.493, and this will be our, for red, if it is for red, this will be this value, that is plus 0.7 should be placed here in a B minus Y position. Next for R minus Y weighted signal, similarly if we consider red, 0.877 into R minus V, where we need to add the value here is minus 0.3, this has to be replaced with here this R minus V position. So, that we will get the chrominance with the weighing factors. So, that is equal to 0.63. This is how we get the chrominance signal with the, along with the weighing factors, and this chrominance signal will always give the information of amplitude, since if it is having high amplitude means it is having a high saturation or U factor. It is having no amplitude or it is having 0 means it is of white in color. Next, this also shows after getting the, after adding the chroming factors, how this color bar signal will looks. Let us have a look here. Before it is crossing this 0% line and it is also above this 100% line. From the weighing factors we overcome this. Now, it is lying between 0% line to 100% line. This is what the desired color signal, that is obtained from adding weighing factors along with the color difference signal. Next, we move on to the very important technique that we are using today. The standard of TV is PAL color system, which is one of the standards used for a color TV system. The important factors we need to consider in the system are the weighted B minus Y and R minus Y signal are modulated, that is without being a given phase shift. We are not going to use any phase shift for R minus Y or B minus Y, that is of 33 degree phase shift is not used in a PAL system. And also the both the color subcarrier frequency that is used in a PAL color system will be of 2 into 283 plus 1 of 15,625 divided by 2. This will going to give us a 4.43 megahertz. This will be chosen, this is very important, we need to note down. For PAL system, the subcarrier frequency will be always 4.43 megahertz. So, why we are going to use 4.343 megahertz? Because this will be helpful in removing the interference. Removing interference can be helpful with the using 4.43 megahertz frequency. So, after the modulation of color difference quadrature signals also have to be allowed with the same bandwidth, and what is the bandwidth that we are going to use in PAL is, that is 0.3 megahertz. 0.3 megahertz will be the modulation bandwidth used, and this will going to result in better color production. And the chroma signal is of vestigial sideband. This chroma signal will always appear in the sides of the color signal. So, the upper sideband attenuation slopes will be have 0.57. Since it is appear on the 0.57, the actual total color or picture information will be having 5 megahertz. This minus 4.43 will be a 4.43 will give us 0.57 megahertz. This will be the frequency of a chroma, but the lower sideband extends to 1.3 megahertz. This is the minimum will be this, and the maximum will be of 1.3 megahertz for a chroma color signal. This is the subcarrier frequency for a chroma color signal. Next we move on to some of the things that we need to know with the help of phasor diagram of the modulating color signal, that is sequence modulation, phase change of V signal on alteration lines in the PAL color system. How? With the PAL name itself says there is a phase alteration in line. So, in every line there will be an alteration. So, what type of alteration we need to do means, as we said, there will be two different modulator for R minus Y and also B minus Y. So, this weighted B minus Y and R minus Y signals are modulated with the phase of subcarrier. So, what is the subcarrier frequency? That is 4.43 megahertz. We have to modulate the B minus Y and R minus Y separately with this subcarrier frequency. So, suppose if we consider V modulator, that is reversed from another modulator, and this will going to give a phase shift of 90 degree to minus 90 degree at the line frequency, that is line frequency in the sense horizontal line frequency. So, that is why we call this as a phase alteration by line. So, the color signal will be having a phase shift of 90 degree to minus 90 degree of line frequency, that is why it is called as phase alteration in line. This mode of modulation cancels the U factor, that is why we are considering phase alteration line, because it is going to cancel the unequal phase shifts in the U factors, that is U errors, which will going to cause a U error. So, we need to cancel the unequal phase shifts, and also the weighted signals are referred here. After applying the resultant phase, we will get two signals, that is U and V. After having the weighted factors along with the signal, we refer this as a U and V component of the chrominance signal. So, this is represent here clearly. The color bus reference will be minus by here, this is the axis line, U axis length, this is the V, and this will be having 90, plus 90 and minus 90 phase shift, and U will be equal to 0.493 of B minus Y, and V will be equal to 0.77 R minus Y. This should be value of V and this should be value of U. So, finally, we want a resultant chrominance signal for a phase alteration in line. So, what will be the chrominance signal? That is equal to U sin omega st plus or minus V cos omega st, that is also equivalent to root of U square plus V square sin omega st plus or minus theta, where tan theta, the instantaneous value, can also be obtained, that is equal to tan inverse of V by U. This will going to give a 90 degree phase shift can be observed here, and here we are getting a minus 90 degree phase shift for each line. For n line we are getting 90 degree, for the next consecutive line, that is n plus line, we are getting minus 90 degree. That is why this technique is called as a phase alteration in line. So, in every line we are getting a phase shift of plus or minus 90 degree. So, next we move on to Part-13-Colour system. How this all the signals will be going to generate in each block, and what will be the input and what will be the output. So, improvement occurs because in PAL system we have a delay line, if that is employed to for averaging first and then present the color to the ISO. We have a delay line that will going to improve a PAL decoder, that is known as PAL D or delay line. PAL D will be this here, the delay line will be applied here for the chrominance bandpass. This will be helpful for I to recognize the color. For convenience, both U and V have been assumed to be positives. Therefore, the corresponding shade of magneta, we will get U and V will be positive here, and we will get some of the shade, that is of purple shade or magenta. First line, when the U modulator product is at 90 degree to the plus U axis. If it is in U axis and it will be having plus, it will be in a plus axis, that is U will be in a plus axis, we will get a V that is of out of phase of plus 90 degree. The phasor can be expressed with the U plus JV. So, U plus JV will be the resultant. So, we will get a U plus JV here. This is also used in a NTC, and this line is also called NTSC system, it is National Television System Committee, will also use the same technique U plus JV. The next line, when the first line will be this, that is N line. The next line how we will get, when V phase is switched to minus 90 degree, the phasor becomes U minus JV. So, here this is having plus 90 degree phase shift, that is N line, N plus line will be having minus 90 degree. So, that the resultant phasor will we get is U minus JV. This is called as a PAR line, this is as a NTSC line, this will be a PAR line will be get. So, U minus JY what we get from the chrominance band pass amplifier, this will be a PAR line, this will represent the NTSC line. So, this is a line numbers n minus 1 to n, n plus 1, n plus 2, so on will be considered. This is the direct signal, that is from the video preamplifier. After that we will get U plus JV as NTSC signal and U minus JV as a PAR line signal. The next line will be a delay line. This will be half of 64 microsecond. Adding and subtractor circuit will be there for demodulating this 2U and 2V. So, here we should get 2U and 2V with the help of adder and subtractor. The signal will be having a delay, then because to get a clear picture that is comfortable for the eye, we need to add a delay line here, that is having a 64 microsecond of frequency. So, after adding and subtracting, we will get 2U here in the U modulator, U demodulator, and also in 2V in the V demodulator technique. So, these two are the inputs to the demodulator. So, after that we will get a particular U and V from the demodulator amplifier. So, at a frequency of 4.43 megahertz, the number of cycles which takes place, how many cycles will be takes place with the 4.3 megahertz frequencies, that is 64 microseconds are 4.43 into 8 power 6 into 64 will gives us 283.74, that will be approximately 283.5 will be the cycles that can be appeared. So, the delay line which introduce a delay, that will be equal to 283.5. So, for every cycles of a signal we will get a frequency of 283.5. So, next we move on to the choice of color subcarrier frequency. What should be the subcarrier frequency in the transmitter, so that we can easily transmit the color information with the subcarrier frequency. The actual relationship between the Fs, that is the subcarrier frequency, horizontal frequency and vertical frequency, that can be expressed with this. This is an important formula that will going to give us a 4.43 megahertz, where Fh divided by 4 into 2 into 567 plus 1 plus Fv by 4 is equal to 4.43. This is what we get generally used before using this. We discussed in the previous slide. Next we move on to part decoder. Knowing with all the knowledge that we get from the Y, how the formation of luminance and the color difference signal, this has to be added with the adder. So, this will going to give a sync pulse here, and we get next we send this to a delay line, because this B minus Y is already in a delay. So, we also add a delay line to the Y also. After the delay line, it has to be sent to the adder. Similarly, the B minus Y and R minus Y should send to the low pass signal filter if any filtration has to be done. So, U and V will be get, and this has to be sent to the adder circuit, where next it has to send to a modulator. Modulator will send this to the adder, where U and V will be added, and here the subcarrier frequency of 0 and here the subcarrier frequency will be of plus or minus 90 degree will be given to V through the multi vibrator, which will going to give a 7.8 megahertz frequency, and here in the blanking and sync pulse generator we will get the frequency dividing count also. This will be helpful for giving a burst signal that will going to give a subcarrier information that has to be sent through the burst gate to the adder, so that this information, the subcarrier frequency also added to the V signal. So, this will be finally comes and add up in the adder. So, finally, the C will be having both the U and V, and this has to be sent to the adder along where the Y also present, so that we get all the color signal. This appears to be the burst signal, and this is the color signal with the color difference and the luminance information. It has to be sent to the video amplifier and finally to the main transmitter for transmission. This is how the video signal looks, and this is the modulated carrier color signal. This already we studied in detail in the formation of chroma signal. Next we move on to merits and demerits of PAL. In merits there is no problem of differential phase errors because we are going to use a phase alteration in line. That is a technique we are going to use, that is why we do not get any phase errors in the PAL system. And the demerits are use of phase alteration by line technique and associated color circuitry together makes the PAL system more complicated, that is why it is having it is expensive, and the receiver cost is higher for PAL color system. The PAL system present problem because of magnetic recording, since a complete color coding sequence requires 8 fields instead of 4 necessary in the NTSC. So, these are the demerits of a PAL system. Let us have a quick summary of this session. What we studied about the B minus Y and R minus Y signal, which is having a over modulated due to the factors, that is it is reaching more than 100% saturation. This has to be overcome with the help of weighing factors for R minus V and B minus V. And also we come across the subcarrier frequency that has to be considered, that is subcarrier frequency should be as 4.43 for a PAL system, with the formula is this. And finally, we also come across the subcarrier frequency will going to be chosen in such a way that 4.43, because this will going to remove the interference and will going to give a clear output. So, this is a summary of the session. Let us have some questions. How do we obtain chrominance signal? Explain with a suitable block diagram the encoding process in the PAL colors system. The references are engineeringtv.com, tvtechnology.com. Textbook references are basic television principle and servicing and television and video engineering. This ends the session. Thank you.